Hello, today we are going to be looking at vectors using their components, and we'll learn today what components are. Now, unit vectors are a vector with a length of 1, and if it's a length of 1 in the horizontal direction, we call that vector I. If it's a length of 1 in the vertical direction, we call that J. Now let's label these. This one right here is going up 3, so that would be 3J. This one is going to the left 1, 2, 3, so it's going negative 3I. This one's going down 2, so it'd be negative 2J. And this one's moving to the right 1, 2, 3, 4, 5, 6, so I can call that 6I. So that's how we can name these vectors. Now if we want to draw them, 3I, I'll draw 3I here, going 3 to the right, and I'll drag that over to a good location. I'll bring negative 2J here, I'll start it there and then go down 2. Negative 7I, I'll bring here, and I'll start here and go 1, 2, 3, 4, 5, 6, 7. And I need an arrow at the end. So that's negative 7I. And 5J would be, I could start here and go up 1, 2, 3, 4, 5. And this could be considered 5J. Alright. Hopefully we understand how these I's and J's work. So if I wanted to add them together, 3I plus 2J, what that means is I go 3 to the right and 2 up. So I started here and I ended there. So this vector is, this is 3I, this is 2J, and remember when we add vectors we go from the beginning of the first one to the end of the second one. Alright, now this is a little confusing for people, but this red part is the only thing that is 3I plus 2J. Now if I did negative 7I plus 5J, I'll start over here. Negative 7I would go 1, 2, 3, 4, 5, 6, 7. 5J would go up 1, 2, 3, 4, 5. So this vector starts in this corner and goes up there. And the only thing of interest, maybe I could even color it, just so we know that that orange vector is the only one that this represents. This bottom represents the negative 7I, that represents the 5J. Negative 7I plus 5J is the orange vector. Alright, so hopefully you guys are getting the hang of this. We'll just do one more. If I start here, I go 2 to the left and 4 up, 1, 2, 3, 4. So this vector right here represents negative 2I plus, oh, look at me. I didn't even see that that was a negative sign. So let's do this again. I'll start here and go 2 to the left and 4 down. 1, 2, 3, 4. And now this represents negative 2I minus 5J. Alright, moving on. Now if I want to write this vector as a sum of its components, what I have to do is look at how far it moves to the right and how far it moves up. This moves to the right 1, 2, 3, 4, so that's 4I. This goes up 2, so that's 2J. So this vector is 4I plus 2J. Now if I want to find the magnitude of that vector, so the vector is 4I plus 2J, and the magnitude of that is going to be, we can get that using Pythagorean theorem. So 4 squared plus 2 squared, and square root that to get our hypotenuse. So 16 plus 4 is 20. Now I can take a root 4 out of that, so that would be root 4 root 5, so this would be 2 root 5. So the magnitude is 2 times the square root of 5. Alright. Now what angle does this create with the positive x-axis? Well, if this is 2 and this is 4, they're looking for this angle. So what I would just do is say the tangent of theta is equal to 2 over 4. So I take out my calculator and take the inverse tangent of 2 over 4, or 1 over 2. And this is 26.565. So that's the angle that this vector makes with my positive x-axis. Write the vector as a sum of its components. Now you pause the video and do this one on your own. This is negative 2i. This is 3j. So this is going to be negative 2i plus 3j. Put my little vector symbols on top. What's the magnitude of this? Well, if that's 2, that's 3. It's going to be 2 squared plus 3 squared. And take the square root of that. So that's 4 plus 9, which is 13. We cannot reduce that, so this is just the square root of 13. What is the angle that this makes with the positive x-axis? So we're looking at that angle there. And this is 2. I guess we can say negative 2. This is a 3. So if I take the tangent of theta is negative 3 over 2, or 3 over negative 2. I take the inverse tangent of negative 3 over 2. But what I should have done is taken the arctan. Alright, so when I take the arctan, this is going to be the inverse tangent of negative 3 over 2 plus 180n. So really this is negative 56.3 plus 180n. Now we need to think about this. Is this angle negative 56.3 degrees? Hopefully you're shouting, no, no, because negative 56.3 degrees would be this one. So we need to add 180 degrees to that to get theta is going to be 123.7. Alright. Write the vector as a sum of its components. So this is C. I'm moving 1 to the left, negative I. I'm going to go down 4, so negative 4j. So this vector C is going to be negative I minus 4j. If we want to find the magnitude of this, we have negative 1, negative 4. So it'd be 1 squared plus 4 squared. Square root that to be C. So that's 16 plus 1 is 17. So the magnitude is the square root of 17. What is the vector of the angle in standard position? This is the angle we're looking for. So this is going to be 4, negative 1. So the tangent of theta is going to be negative 4 over negative 1, which I just take the arctan of 4, which is the inverse tan, which is 75.96 plus 180n. Hopefully you can look at this and see that it's much more than 75.96. So if I add 180 to that, you'll find that your angle is 255.96. Alright. Write this vector as a sum of its components. So we're moving to the right 4 and down 5. 1, 2, 3, 4, 5. So it's going to be 4i minus 5j. Alright, hopefully we're getting used to that. So let's do something like we're going to be adding vectors using components. So if I have 2i plus 7j and f is 4i minus 3j, find e plus f in terms of its components. Well, if this moves it to the right 2 and this moves it to the right 4, e plus f is going to move to the right 6. Now if this moves it up 7 and then down 3, in the end it's just going to be up 4. So 6i plus 4j is e plus f. Pretty easy. Add the i's, add the j's. Find b plus t, or b plus d in terms of its components. Well, this would be a negative I. This would be minus 3j. So that's b plus d is equal to that. Now find b plus d as magnitude and direction. Well, if we look back at this, negative I minus 3j, that means I'm going to the left 1 and then down 3. So we're down here. So the magnitude is going to be 1 squared plus 3 squared and then square root. So the magnitude of b plus d is going to be 1 plus 9, which is 10. So we do the square root of 10. Now if I want to find the direction, we're looking at this degree measure. I just take the tangent of theta is equal to negative 3 over negative 1. So theta is going to be the arctan of 3. And remember, hopefully, everyone knows that arctan is the inverse tan plus 180n. The inverse tan of 3 is 71.57. Oops. Switch colors on you. If we look at this, 71.57 is not reasonable, so we'll add 180 degrees to it. 250 degrees is reasonable, so we'll say that the direction is 251.57 degrees. Alright, write this vector as a sum of its components. So first thing we need to do is try to map this out. Let's call this x and this y. So to find x, what we have to do is use cosine. Cosine of 72 will be x over 12. Multiply 12 on both sides. 12 cosine of 72 will be x. Now if I want to do that for my y, this is opposite over hypotenuse, so the sine of 72 is equal to y over 12. Multiply 12 on both sides. 12 sine of 72 is equal to y. So if I wrote this as a sum of its components, I could say 12 cosine 72i plus 12 sine of 72j. Now we just have to do the math on our calculators. 12 cosine 72, that's 3.7i, plus 12 sine 72, 11.4j. And now we can look at this and think, does this look reasonable? Does this look like this is about 3.7? I could see that. Does that look like it's about 11.4? I could see that. So that looks fairly reasonable. Now, if v is a vector in the direction of theta in standard position, then vector xi plus yj, where x is the magnitude of v times the cosine of theta and y is the magnitude of v times the sine of theta, we'll know that if we want to write this vector in terms of its components, we'll write it in this form. the magnitude times cosine of theta I plus magnitude times sine of theta j. So if we look back at how I did this previous problem, it's the same thing. Magnitude times cosine of theta I, magnitude times sine of theta j. And that will give us our components. So this is the formula that we need to have. Alright, that makes problems much easier. So in this situation, we know our angle is 142, we know our magnitude is 8. So if I want to find vector v, let's call this vector v, it'll be 8 cosine 142i plus 8 sine of 142j. So then we look at 8 cosine 142. That's negative 6.3i. And then 8 sine 142, 4.9. So that's my vector v. Now does it make sense that I'm going 6.3 to the left? Yeah, that works out. 4.9 up. That seems reasonable. So that looks like that's that vector as a sum of its components. Draw vector C at 14 units at 30 degrees, vector D 5 units at 348 degrees. Write each vector as a sum of its components. Alright, so that's not the one I wanted. Well, that looks better. Let's get rid of this. Alright, so let's do vector C. 14 units at 30 degrees. I'll even use this one, just so. So 30 degrees, let's call that 14 units. And then let's do D, 345 units would be down here, and 5, it's much smaller. Alright. Now, if I want to write each vector as a sum of its components, this is vector C. And vector C would be 14 cosine 30i plus 14 sine 30j. 14 cosine 30, so that's about 12.1 I. 14 sine 30 is 7, plus 7j. My little vector things up here. Now if I have vector D, we would find that by 5 cosine 345i plus 5 sine of 345j. 5 cosine 345 is 4.8i plus, oops, I should say minus. I should have known that before I even put it in my calculator because it's going down. So that would be minus 1.3j. Alright, so now we have vector C and vector D written in terms of its components. So let's write C plus D as a sum of its component. So we just look over here. C, if I want to find C plus D, we just add these together. So 12.1 plus 4.8 gets us 16.9i. 7 minus 1.3 will give us 5.7j. So if we add these two vectors together, it would be 16.9i plus 5.7j. 16.9, 5.7. That's C plus D. Put some vector symbols in here. Alright, now let's write c plus d as magnitude and direction. So I'm going 16.9 to the right, 5.7 up. So if I just made a quick sketch, oops, that's not what I wanted. It would look something like this. 16.9, and this would be 5.7. So its magnitude is going to be 16.9 squared plus 5.7 squared. Add them up, square root them, and that's going to be the magnitude of c plus d. 16.9 squared plus 5.7 squared. Square root that, 17.8. So 17.8 is going to be my magnitude. Now my direction, that's theta, I would get by taking tangent of theta is equal to 5.7 over 16.9. So here I could just take the inverse tangent because it is between 0 and 90. So that angle theta is 18.6 degrees. Alright, hopefully that was enough to help you with the homework. And here you go. Good luck.